Hi, I'm here in Darwin College at the University of Cambridge, where, in a second, I will be joined by Torben, PhD student at the Cantor Capital Institute for the Mathematics of Information. Oh, there he is! Hi Mr. Sell, nice to finally meet you. Shall we go punting while you interview me? That sounds fun, let's go! I'm so excited for this. Torben is one of the best mathematicians in Cambridge. And what now? Please take a seat. So Torben, tell us what you do in your research. So I'm looking at value function estimation and uncertainty quantification in Bayesian inverse reinforcement learning. That sounds super interesting, but I have to admit I don't really understand what you were saying. Could you maybe explain it a little bit more? Of course. So look at the river in front of us.
When punting, there are some regions that we want to avoid and one region that we want to reach. This can be modeled by a reward function. When we have a reward function and we also have a strategy on how to punt, we can calculate the expected reward at each point. As reaching the region now is better for us than reaching it in 10 hours, we apply a discount factor when calculating this accumulated reward. This is the value function. Note that the value function depends on the policy that one follows. Now, forgetting everything I said before, if one is given a value function, one can define a policy by choosing whichever action maximizes this value. For example, when punting, we can accelerate, slow down, or steer left or right. In my research, I try to estimate the value function when given only some state and action pairs. For example, I might watch a few people punting and record which actions they take in certain situations. Using this data, I can learn the value function and then use it to mimic the punter's behavior. While this is a standard problem that is solvable in many ways, I am trying to include uncertainty quantification by choosing a Bayesian approach to the problem. This allows me to sample from a distribution over possible value functions. The mean of this distribution gives us an idea of what the average punter's value function might look like, while the variance shows some variability between them. We can see that all punters try to avoid bumping into the wall, while they act differently when in the middle of the river. Punting, however, is not the only application for this. Other applications include control theory, game theory, operations research, swarm intelligence, genetic algorithms, simulation-based optimization, information theory, multi-agent systems,